Hey everybody, and welcome to Advanced Windows 8 Apps with JavaScript. I'm Jeremy.
I'm Michael.
And we're going to have a good time. If you were here for our previous courses, you kind of know what kind of a good time we're going to have. You may have been here for our 480 and our 481, and now we're talking about preparation for the exam of 70-482. This is on Advanced Windows 8 Apps using JavaScript. So is everybody buckled up and ready to get started?
Let's do this.
Okay.
Well, let's first meet Mr. Jeremy Foster. His Twitter alias is @CodeFoster. Jeremy joined the team over a year ago. He is a peer of mine on the team. He is recognized heavily for his education and his experience in the education field, as well as the aerospace manufacturing and insurance. I'll tell you what my experience is with Jeremy. He is just spot on with regard to technical content. He knows how to really relay information about very complex things in a way that anybody could understand. So it's a pleasure doing this Jumpstart with him. Of course, you could see his information on the screen with regard to how to contact him and read some of that great content that he's done, such as codefoster.com. Also, I think he's going to be showing you a little bit more about some of the tweaks and advancements we've made at codeshow.codeplex.com. And what do you mean there by your little CSS book? Are you trying to promote something?
Well, it's just a little book I wrote, so yeah. I mean, if it helps, go for it. But
I see. So definitely you want to check out his new CSS book at the aka.ms/CSS book. So, very nice to work with you again, Jeremy. This is going to be a fun day.
yeah, it's going to be fun. So then I'm working with Michael Palermo. I've been working with him since I started at Microsoft just a little over a year ago. And you can find him online, Palermo4.com, on Twitter @Palermo4, and definitely also a very profusive creator of online content. So you'll find plenty of help from Michael as you're trying to come up to speed on all things web stack, all things Windows 8, and hopefully you get an opportunity to see him live as well, because he's a dynamic presenter.
Interesting. Hey, while we're on that slide, I do want to mention that the second link there, the aka.ms/70-482, I set that up as a little place that if anything comes up and I'm like, oh yeah, I want to be able to provide a little future updates, there's something that can go there, so that's why that link's there. It's a blog post right now that's just promoting this event.
What's that aka.ms?
That's one of those little short URL things that just makes it so easy to remember the other side of the slash.
All right, so it's kind of a bit.ly? Or...
Yes.
All right. Also known as.
True that.
Okay, let's show my screen here. I want to give you a little introduction to what you're participating in today. This is a jump start, and if you're not familiar, a jump start is really a jump start into a given technology and a preparation for the associated exam. Now, a jump start is accelerated certification preparation. So you're not going to get the same content that you get out of some sort of a deep dive series or out of a book, but we're going to hit all the points that you're going to hit on the exam. You're going to get that conceptual, high-level view of what it is that's going to be in the exam, and hopefully you're going to get some real content as well. So you're going to see stuff on the screen, but you're not necessarily going to be walking through hours of online labs or anything like that. So that's the nature of a jump start, fast-paced, real-world, and straight to the concepts. Now,
yeah, and you know, I just want to interject on that. I think one of the things that was so fun about doing the last one is even though we maintained that, the course, we want to help with the exams, which were successful. We really wanted to throw in the real world aspect too. I mean, in fact, that was almost the primary driving force. It just happened to be helpful in the other areas. So same thing's happening today. Yeah,
absolutely. And we heard from a lot of you that watched the series and then passed your 70-480 and or 70-481 exams. So to all of those people, huge congratulations. That's really awesome.
Very cool.
Huge.
We receive information all the time.
Yeah.
I mean, it's almost a daily thing. I check the Twitter feeds and so forth. Another person passed the exam. So congratulations to every one of you doing that, and we hope to have more success stories for you from today.
Yeah, and let me just say, keep it up. If you pass the 480 or the 481, or after this, pass the 482, please just go ahead and tweet that out and let us know, and then we'll all be able to congratulate and share. So that's really awesome. Now, the course, I wouldn't necessarily count on the Jumpstart course as your sole means of preparing for this exam. Now, there were people on Twitter that said, I watched the videos and then I passed the exam. But then there were a couple that said, I watched the videos and I took the exam, and there were a couple questions that kind of threw me a little bit. And that doesn't surprise me at all. There's no way in 6 hours of content to prepare for everything that's going to be on those exams. They're really comprehensive, very comprehensive. So definitely watch the whole video series. It's recorded, so you can go back and watch Michael Palermo talk in slow-mo, if that helps you to receive the content. But definitely go back and watch those, and but then also find some content online. The thing that I found the most helpful is to go to the Skills Measured for the official course section site, and go through that Skills Measured and just go hit each of those points, and just, you know, bing them and make sure that you understand everything that it says it's going to cover. That's real important.
And the other thing that I would mention too is that, of course, many of you are looking to do this for exam as a goal, and that's great. But why not get an app made as soon as possible? Let that real world experience be the guide that helps you to really pass that exam. So get the app really done. Go through the whole journey with the app, and you'll see that that's really what's going to make that content stick in there.
Yeah, there's actually really a whole lot of potential in the Windows marketplace right now, in the Windows Store. I know that there are already a number of people that have passed that $25,000 threshold, and as you may or may not know, the $25,000 threshold is this: before you make $25,000 in the store, you get 70% of your proceeds, but after $25,000 you get 80% of your proceeds. So boom, you know, you really up ramp there. So anyway, there's a lot of potential in the market, so make sure you're working on an app. And if you need any help with that whatsoever, is there any way that we might be able to help them one-on-one?
Yes, as a matter of fact, both Jeremy and I are involved with with a new thing that we call office hours. So we're going to be plugging our URLs for that at some point, so that there would be opportunities for you to even grab one-on-one time with us, whether that's virtually or if you happen to live in the area we live in, we could do that too.
Yep. So mine is ohours.org/codefoster, and what's your link?
ohours.org/Palermo4.
There you go. Heard it here first. All right, so there were a number of changes to Code Show. We're going to talk about that in just a second, but first an overview of the day. 6 modules. We're going to be talking in the first module about background tasks and components, and a little bit of extra stuff in there. Module 2, we're going to be talking about hardware and sensors and how to communicate with those and make the user feel like their device knows where they're at and what orientation the device is in, and all of that stuff. Next, Module 3, Printing and Play To, and we're also in that module going to talk about the push notification service. So quite a bit of rich and very technical content there. We'll take a break, and then we'll talk about Module 4, Animations, writing your own custom controls, and globalization and localization strategies and options. And Module 5, Data and Files and Encryption, and how to handle the storing of data and also the protection of that data. And the final module, Module 6, we'll talk about various deployment concepts, testing your app, monitoring and performance monitoring your app, things like that. So that's really what we've got in front of us today. So I want to walk you through the Code Show project, what's new with it, where we're at with that. So as you may know from previous Jumpstart videos, the Code Show project is our way of delivering the source code, the content for this Jumpstart series to you. You may remember from last time that it was hosted in Codeplex. It still is. And you may remember that we asked you to download it from CodePlex, install it on your machine, and roll with it. It still pretty much works that way, but there are a couple of other improvements, I'll call them. I think they're improvements in various ways. First of all, if you go to aka.ms/CodeShowApp, that's the short link that'll take you right to the Windows Store landing page for the CodeShow app. So you can go download, if you're running Windows 8, you can go download CodeShow for Windows 8. So it's a running Windows 8 app, and the thing that we had tried to do in that app is there's a see the code button on every single demo. So if you hit see the code, it's going to take you to the HTML, CSS, and JavaScript behind that page. Now let me just air my dirty laundry here. I'm ashamed of the fact that I still don't have the ability to go copy that code out of the see the code page. That's tragic, but hopefully that'll be resolved at some point in the future when we get more than 24 hours in a day.
Sure.
I think that's supposed to happen soon.
Oh, good.
Yeah. So anyway, that's one way that you can interact with the code from CodeShow is just to go download the Windows 8 app. The second way is to still go get the source code. So the landing page for CodeShow is codeshow.codeplex.com, just like it's always been. But there's one significant difference. If I just take you there to codeshow.codeplex.com, the one significant difference here is that if you go to the source code tab, just like you did before, now you'll notice that the terminology here is a bit different. That's because the CodeShow project on CodePlex has been modified so that it's now using Git as its source control. It's really exciting that you can do this because Git's better at opening up the collaboration to the community at large, and that's you. So we want you to not just get with Git, no pun intended, get CodeShow, but we also want you to contribute back to CodeShow.
Well, Jeremy, what about those that might just want to, just get a snapshot of it? Is this whole Git thing going to make it so that they can't just download what's currently there?
Well, that's a good point. Yeah, Git has a little bit of an up ramp as far as figuring out how it works. I want to try to make that easy for you, but there's a little bit of an up ramp. So if you just want to download the code, you still can. If you're on the source code tab, there's a download button. Actually, the instructions are the same as before. You just click on download and you're going to get a link to the zip file. Download the zip, extract it, you've got it. You're ready to go.
That's
okay. But if you want a more dynamic connection, then what you want to do is you want to install Git and clone it. Now, the easiest way to install Git on a Windows machine, in my opinion, is to go to windows.github.com. And even though you don't need to use GitHub, because that's what we're using CodePlex for, when you install GitHub for Windows, it actually installs all the dependencies that you need, and it gives you this handy thing called the Git shell. I'm going to open the Git shell for you real quick, and you'll notice it looks familiar. It looks like PowerShell because it is. And the Git shell is going to be your command line interface for cloning your project. And when you're in there, you want to clone the CodeShow project, and all you have to do that is to go into the clone link, and it'll give you this URL that points to that repository. So in your shell, you just type git clone that URL, enter. You'll see it'll take a few seconds because it's not just downloading one snapshot of CodeShow. It's actually downloading the entire repository, including all of its history. Okay?
Cool.
Now, if you want to contribute, the way to do that is to click here on fork. And in your CodePlex account, you'll be forking the CodeShow project and creating your own online repository to which you can push changes to and then do pull requests.
Cool.
All right, so that means that you say, hey, CodeShow people, I made a change that I think is a value added into the CodeShow app. So here's a pull request. Can you please pull this into the CodeShow project? We'll look at it. Hopefully pull it in, and you'll be a CodeShow contributor. Woo-hoo. That is highly encouraged. We really want to crowdsource CodeShow and make sure that lots of people get the opportunity to not just use it, but also submit to it.
Sure.
Now, the first thing you need to do after you either download that source code or clone that project in Git is you need to go into the packages folder and you need to install those packages. Otherwise, you're going to get invalid references in Visual Studio because it needs these.
All those dependencies.
Right, exactly, those references. Let me just jump into there real quick. I'm going to take you into the CodeShow project where I have it stored locally, and you'll have this too after you clone or download. You'll have the packages folder. And you open that packages folder, and there you go. These are Windows installers, VSIX files that install as Visual Studio plugins, MSIs, things like that.
Excellent.
Yeah.
Cool.
Now, just one extra note, it does require Windows 8 and Visual Studio 2012. So we got a couple comments last time, people saying, hey, I got Visual Studio 2012 running on Windows 7. I'm not able to run the Code Show project. It is a Windows 8 app, and in order to run Windows 8 apps and develop in Windows 8 apps, you do need Windows 8. So there are various ways to virtualize that. Actually, I've got a blog post on that. If you just go to codefoster.com/ready, I'll talk through all the different virtualization strategies. If you've got a Mac, you can virtualize it on there, whatever.
Cool.
Anything to add there, Mr. Michael?
Nope. I'm excited that we have a much better product and code offering this time around.
Yeah.
It's great.
Yeah. Really looking forward to those contributions.
Yeah.
Well, do you suppose we should jump into Module 1?
Let's do it.
Let's do it.
So if we can switch over to my layer, so to speak, we're going to be getting into, first of all, background tasks. We're in Module 1, and specifically the agenda that we have right now is creating background tasks. But let's first ask what it is. And the real simple, robust line here is to run code even if the app is not running. Now, I look at this in a kind of a special way. You know, our apps are when we think of an app, we think of it as a foreground app. The app is the main, it's the rock star. It's what you're doing with the app. But a background task, it's not like that. In fact, a background task, when you create an app with a background task, in a sense what you've just done is you've created two apps. But you created the foreground app, that's what's going to be interacting with the user. But then this background task is kind of the one that's doing all the dirty work behind the scenes, and its sole purpose is kind of like a manager to a rock band. I'm going to do all the behind the scenes stuff to promote and make sure that this app is always in the foreground even when the app is not running. Think of it that way. I also look at it this way, that if the app could sing a song, if your foreground app could sing a song, it would sing to the background task, "You are the wind beneath my wings." Because
could you expand on that?
I won't sing it, but the reason why is because it really is doing all the work to promote the app. It gets no glory in itself. So that's what we're after. Why? Well, because if your app's not running and no one is around to say, "Hey, look at me, look what new stuff is around," well then your app might just get forgotten. So it is your rockstar manager. Now, when we consider features that are already available, and we're going to tie into some of these throughout the day, but background tasks can be used for Windows push notifications, can be used for the playback manager for audio in the background, and also for transferring, uploading and downloading files, and for share contracts. Share contracts are probably easy to remember. Something can share to your app even if your app isn't running at that time. Again, this is a facility that's done in the background. Well, what would be appropriate scenarios for a background task?
Now, Michael, let me interrupt you. Isn't Windows a multitasking environment? I mean, aren't we always able to do things behind the scenes?
Well, it is a multitasking environment, but you have to remember, in our little Windows Store app world, our application, when it's running in the foreground, it is the main star. But as things get cycled through, your application might get suspended, and when it's shut down, it's not running at all. So this is why we need this, so that something can kick in the background and represent, so to speak. So think about some background tasks that might be common. Think about an email client. I mean, how beneficial would it be if you had a mail client that never told you something new had come in? Or what about if someone wanted to chat with you and your app didn't happen to be running at the time, and you were never notified that someone was trying to chat with you because you didn't have your chat application open? Or you wanted to update some kind of a service to indicate, oh, you know what, the user's now present, so let's do something. Maybe let's log that information, whatever the case is. But it's also important to talk about what it's not appropriate for. Background tasks should not be used as a means to dump. I mean, think about the manager again. You don't want to dump a whole bunch of work on your manager behind the scenes, busy enough already trying to, keep in with the times and finding out, is there any new information that I can bring to the table? So you're not going to do extensive workloads. You're not doing exhaustive background. In fact, you are limited to the amount of processing time you're going to get with your workloads. And anything requiring user interaction. And what I mean by that is that there's nothing that will actually prompt the user outside of these things. A tile notification, a badge notification, a toast notification. So we want to make sure that those things are understood as UI, but you couldn't actually create a custom UI in your background task to promote. You can't just do that. You have to think of it as, I'll indicate this through some other channels or just through writing through some background process. But you can't engage the user directly through a background task. So let's get into how we can actually create background tasks. I think of it in these simple steps. You create what's called a JavaScript worker file. Then you're going to implement whatever it is in that particular file that it's going to do. Remember, it engages nothing with the user in the UI. Then you need to register that worker file content as a background task. And then finally, you declare that background task in the application manifest. So let's take a look at like a shell of this JavaScript. You'll notice that task.js, which is the name, and by the way, you can name this anything you want. Freddy.js, Lou. I don't know if you have any other names that you wanted to throw in there, but task.js is what I call this one. So keep in mind, you can call it what you want. But I have a comment in there that's important. It says it runs in the context of the worker global scope. What that means is that if you look at the very bottom where it says close, see that close method is available because the close method actually is part of that worker global scope. So when your background task is running, it's running in a different context. It's not like a Windows where when you're in your app, it's window dot or document dot. It's not like that. We're actually dealing with the worker global scope. As also part of that, that import scripts is a method off of that worker global scope. So here's the potential. Your task is executed. It may import these scripts. Again, import scripts is part of that, so don't try to use this in your pages. This is just for this task. So I'm importing the Win.js, and the other example there, the js/app.js, that's an example of what if I had some custom content that I wanted to also throw in here, like an API call that I wrote. So that's an example of how I could throw that in there and possibly use code from there. It's very key, though, when you're done with the task, that you close it. So that's, always remember, there's a close method that needs to be called. Then an example of what you could do here is after your imports and before you close, you could access the actual current instance of the task and grab information such as the instance ID, or you can use what's called the get deferral method. If your task is going to do an asynchronous call, then you can use get deferral in order to make that asynchronous call, and even how to handle the cancel event. Now, all the things that were done there were part of that background task in that task.js. But now in the foreground app, you need to create, using the background task builder, the ability to register this task. So you'll see here kind of in three major steps. One, I like to create a little namespace to that windows.applicationmodel.background, so I called it back here. And then I create a background task builder, give the task a name, let the builder know what the entry point is, and notice that I'm using the two backslashes there in the JS backslash task in order to actually make that one single backslash when it gets interpreted. And then I assign the builder what's called a trigger. And if you think about it, triggers, which I'm going to get into shortly, are what make it possible for you to actually invoke these background tasks. And then finally, you register the task. When you go into the package application manifest, this is an example of saying, okay, in my declaration section, I'm going to add a background task, and then I'm going to notice where start page is in the very lower right-hand corner of the screen, it says js/task.js. Now, interestingly, if I go back one screen, you'll see that I say builder.taskEntryPoint equals, and then I provide the path. And then you also see that there's a text box field for entry point, but notice I don't use entry point here. In a JavaScript application, you must use start page as the task, not entry point. So that's not a mistake. That is the way it's supposed to be done. Now, how do you consume these background tasks? First of all, remember, they're background tasks, so that means something is going to fire it. Something is going to make it kick in. And there's a number of ways you could do it. I'm putting on the screen now all the different ways that it can be done, and I'm not going to go into all of them in detail. But like the last one, for example, is a time trigger. It says a time event occurs. So you can actually say, at some point in the future, I need this thing to fire off. And most of these triggers come with the option to have it just fire off once, if it's just a one-shot deal, or you can have it as a permanent task in your application. Tasks can also have conditions. You could say, I want to fire off this background task, but I only want to do so if the internet is available, or if the user is present or not present. So you can add this into the equation as well. And there's some that even require access to the lock screen. The reason for that is because of the potential interaction it can have with the lock screen. And if you do this, if you happen to use one of these type of triggers that require the lock screen, that means in your application manifest you also have to provide the lock screen image, which is just a monochrome. It's either transparent or white. So just remember that now becomes a requirement as well. So let's just see a little demo of what this would look like. I'm going to go to the Code Show app. So that's featured right here in my start screen. I'm going to fire that off. And I'm going to go to the background task, how to register and consume a background task. So I'm clicking there, and it says it's going to show how we can register it so that even when the app is not running, we can see this thing in action. So you'll notice now, if I go back to the start screen, Code Show is just showing with its normal tile. But by merit of going into the application itself, so I'll tab back over there, the code for this actually in the, I forget that we have these wonderful, nice touch screens. This is great.
Yeah. Notice, I wonder why you were using your mouse.
I don't need it. This is great.
You would take that from you? I can just throw it aside?
So in the ready event of this particular page, I am registering the task. I've also included a helper function, this is task running, because I wanted to make sure that if it's already running, and this is a key point, there's no need to register it again. So I've checked to see if it's there, and I'm registering. Well, what does it do? It's ultimately going to register that task, and anytime there is a change in the time zone, I want to update the tile. So now that you've seen that, I am going to close the app. It's not going to be running anymore. So let me go ahead and change my PC settings. You know, I'm from Arizona. I'm not currently in with the whole time. Our whole state is not in sync with anything.
Yeah, you guys don't play along, do you?
Yeah. So I'm going to change now to Pacific time and make that, and go back over to the start screen. Now, look at that. The moment I do that, it said time zone change, even though the app isn't running. The reason is I registered that if there's anything that happens with that time zone, my app wants to be notified. And now it has been. And now it says the time zone has changed. So, that is just a little brief example of how you could implement the background task. There's a whole bunch of reasons that you could do it. In fact, I'll give you another one right now. This is the first app I put in the store. It's just called Tile of Time. And what does it do? Well, it updates the tile so that you can see the time live. So, even though that time is probably not correct.
You can integrate that with your time zone trigger.
Yeah. So I think it's now time.
Yeah, and I wanted to add one thing there. We had a question in the chat room. What's the difference between the background tasks and the web workers? As you know, we've got access to web workers in our JavaScript project. Do you want to give that a shot?
Well, the background tasks are specifically going to be executed even if the app is not running at all. And in fact, it's conceivable that a background task could actually take advantage of a web worker if it needed to do some communication, but you don't think of a web worker as actually running when the app isn't running. Think of the background task as something that's running even when your app is not. And it's important to also realize that your app can also take advantage of the background task even if it is running. So it's both ways, but the primary benefit is probably even when it's not running.
Yeah. Yeah, the way I like to think about it is the web workers are good for spawning new threads and doing something in parallel to give yourself that performance advantage where it makes sense. The background workers, the background tasks rather, are a lot more integrated with the Windows operating system, so they give you those rich triggers. They know when the time zone has changed in your example, things like that.
Cool.
Awesome. Okay, so let's talk about components. WinRT components are a new, I'm in the wrong place, are a new addition to Windows 8. It's a completely new architecture, and I'm sure most of you are familiar with the architecture by now. We showed the slides before. And WinRT is something that the language that you're writing in is actually sitting on top of. And so what we're able to do is find a block of our code, some logical section of our code that is that we want to share with other areas, and we can pull that out of our project. And instead of it being a JavaScript block of code, we can actually pull that out and create something that's written in something like C++ or JavaScript and make a WinRT component out of it. So as you can see on my screen here, on the left side, we've got a logical entity with a little bit of code in it, and then moving over to the right, if we pull that out, we're then able to move that into multiple other projects, and so we get a little bit of reuse. So that's one of the main reasons why we might want to do that. Now the components are going to need to be WinRT. That's what the Windows 8 apps are going to be used to talking to. That's what they're going to need to talk to is WinRT. So this component, when you pull it out, you're going to need to follow. You can write it in C# and write it in C++, but you're writing to the WinRT API. You're creating a WinRT library. So I'm going to show you what that's going to look like. But let's talk about why you would want to do this. I mentioned the reuse. It's very handy for taking one logical piece of code and allowing yourself to use it, for instance, as an engine in a web service, in a client app, and feeding a website or something like that. It's when you pull components out, in general, you get more reuse between your instances.
Is this user interface reuse? Is that why you would use a component? Is for reusable UI?
Yeah, and for instance, if you were going to have instances of your UI that were in multiple platforms, and then you would want to pull the logic out of that UI so that you didn't have that close dependency on it. Instead, it was abstracted, and now you can have your multiple UIs that all talk to the same component behind the scenes. But there are a few other reasons why we might want to do this. We also might want to get the added performance of, for instance, creating a C++ native component that is frankly faster than JavaScript at doing some things. So performance might be one reason. Code reuse and modularity are certainly some huge reasons, but you also might want to pull out a component from your JavaScript app just strictly for language preference. I know that if I'm writing a C# app and I'm more accustomed to JavaScript, then I can write all my C# in a component and still get that rich, fully strong typed language support that C# offers me. But then I can also instantiate that in a JavaScript UI, so I can get all of the UI goodies that JavaScript gives me. So there's a lot of reasons why you would want to do this.
Cool.
Have you componentized any of the apps that you've worked on, Michael?
Absolutely. In fact, Tile of Time, the app that you just saw, the component was written in C# that did the actual updating to the tile that was called directly from the background task. The background task was that JavaScript file. but it actually calls into a component to do some of that work. And it was out of laziness. It was, I really know how to do some of the date time manipulations so much easier in C#, so I got lazy and I just used the component.
Gotcha. Well, that's valid.
I'm glad you agree.
That's definitely valid. I do that all the time. So let's talk for a second about language projections. In case you're not familiar with the way WinRT is structured, WinRT is the core API, and then the WinRT modules and all of the namespaces and the types are projected into your language of choice. If you're a C# guy, that's fine. They're projected into C# and kind of virtualized in your comfortable .NET world. If you're more of a JavaScript person, they're projected into JavaScript with kind of naming conventions and types that you're expecting.
Yeah.
So when you write a WinRT component, that WinRT component is going to be consumable in any of these different language stacks. But little gotcha here for us JavaScript people, you can only write a WinRT component using C++ and the .NET languages, C# and VB. Okay? So you can't create your own component using JavaScript. Not too big of a limitation, just something to note. So let's go look at some components. Now this is the first time that we're actually going to jump into the CodeShow app. So if you want to follow along with this demo and you don't have time to download the source code, remember you can just go to the Windows 8 store and download CodeShow from there. Make sure you search for CodeShow, all one word. I neglected to put code space show in the keywords, so that actually doesn't bring it up, unfortunately. But yeah, I'm going to go ahead and launch CodeShow, and I'm going to scroll to the components demo and launch that. Now, in the components demo, I'm trying to, as with all of the CodeShow samples, we like to keep them super simple so that the concept comes across and you don't have to spend a lot of time coming up to speed on what it is that we're trying to do. So what I've got is a couple of input fields here, and these are going to update whenever I change them. So I'm going to add a 1 into A, and I'm going to add a 7 into B, and I'm going to get the sum of 1 and 7 in Y, and that works for the C++ component, and hopefully it also works for the C# component. In fact, it does. Functionality is very simple, but let's go look at that. Now, if you don't have the source code, remember you can hit see the code at the top, and you'll see this code. It's a little too small to read on my screen, so I'm actually going to flip over to the source code, which I obviously have running, and I'm going to show you where that exists in the project. So if you do have the source code, you can go to CodeShow. The CodeShow project is the one you're interested in, and then you can go into the demos. That's where all the demos exist, and they're usually named pretty logically, and you can look at the components demo. What I like to do is highlight all 3 elements of that page, the HTML, CSS, and JavaScript, and open all 3 of those at once. So here we're looking at the JavaScript. Let's actually start at the HTML. You can see that I've got some real basic HTML here, some divs and inputs. It's just standard HTML. Hope that's not new to you. If so, you might want to jump back and watch our 480 course. But so let's jump over to the JavaScript now. In the JavaScript file, I've got a ready event that's doing pretty little. Basically, all it's doing is hooking up to this input field on the HTML page, and for each of the input fields that it finds, it's running this onChange event, and the onChange event just does the math. Now, if we look in the do the math section, here we're instantiating this calculator cpp.calculator. Okay, so we're creating something by just referencing this calculator CPP namespace. And then just below, we're referencing the calculator CS namespace. Let's go take a look at where those namespaces exist. If I go over to my project, you can see that I've got the calculator CPP and I've got calculator CS, and these are WinRT components. So how did I make those? It's really simple. You just right-click on your solution and you add a new project, and you choose, I've got my environment set up mostly for JavaScript because that's just who I am. But if I go to other languages and choose either C# or C++, I'm going to get the option to go to Windows Store and then add a Windows Runtime component. That's how I created those components in this project. But I've already done that, so fast forward. Here they are, calculator CPP and calculator CS. Let's take a quick glance at the calculator CPP file. Here's the implementation of an add method. That's really all this calculator has, is the ability to add. So I don't think it would be categorized as a fully functioning calculator, but it's decent. And then I've got the calculator H file, and that's the header. So if you know C++, you know that this is the way you do it. You divide those up. Now let's look at the calculator C# example here. And in the C# example, of course, C# makes it just a little bit easier. So now we've got a class of calculator. We've got a public method here called add that just takes 2 parameters and returns the sum of those. Very easy. But a couple things I want to point out here. What I want to point out is that the types that you return have to be WinRT types. Now, some of the native types like int are going to be just fine, but you're not going to be able to return things that are C# specific, C++ specific. It's going to need to be a WinRT type. And that makes total sense. Now, the projection is what's going to handle converting that type into a type that's compatible with the language that you're working in. So if you return an enumerable list, an iterator, I think it's called, from WinRT, then that's going to be projected into C# as a list, and it's going to be projected into JavaScript as an array. So just kind of exactly what you're expecting it to come in as. Another consideration is that your classes need to be sealed. Okay, that's to make sure that there's consistency on the consumer side, to make sure that you don't have classes that are going to be overridden and modified in the client project. So those need to be sealed. There are a few exceptions. There can be some inheritance, but for the most part, whatever comes out as a WinRT component needs to be sealed. Now, the JavaScript then to consume that is exactly what you would expect. We're just referencing that namespace, instantiating that class, and then calling that method. So let's look one more time at the JavaScript file. Here we're referencing that namespace, instantiating that object, and then we're calling the .add method. Now, one thing I want to point out is that let's look at that C# add method here. There's the add method. It starts with capital A, right? Because in C# we start methods with capital A. That's just the way we do it. But when that gets projected into JavaScript, even that gets customized to a JavaScript world, where instead of being a capital A, now we're using it with a lowercase a.
Yeah, in fact, I want to mention on that since we're the ones that potentially could be writing that component, I would stubbornly put the capital A in here, and it will not find it.
Oh, no.
So it's very important that you actually allow the projection to occur.
Yeah. Just go with it. You got to roll with it.
Exactly.
Got to use that lowercase a. It'll scream at you because JavaScript is a case-sensitive language, which is good in my opinion. Okay, so this is interesting what's happening here. They're being projected, we're consuming them. What's actually being created behind the scenes is these files called WinMD files. I'm just going to take a little venture here. We're going to go into the developer command prompt, and from here I'm going to go back to the root and then jump into the Windows folder and then into System32. And then I'm going to jump into a folder called Win Metadata. By the way, I hit tab to autocomplete that. That's helpful. Now I'm inside the Win Metadata folder. Let's just do a little dir and see what's in there. WinMD files are in there. These are the WinMD files that represent the native WinRT namespaces. So you can see how nice and clean it is. There's only a handful there. There's only 15 files. And these are all the namespaces that all of WinRT's API is projected through. Windows.UI, Windows.devices, all of those are projected. And these are the WinMDs that are consumed by the apps and enumerated to see what it is that's available to them. Now there's a little executable here called ILDASM that I can run against, for instance, windows.ui.winmd, and it will bring up ILDASM, and in here I can browse that entire namespace. In here you're going to see the WinRT types, you're going to see the WinRT method names. So this is pre-projection. This is not the exact same names that you see in JavaScript because things get changed. The types and names get changed just a little bit. But you might be familiar with the message dialog space. So let me take you into there. Here we are now in windows.ui.popups.message dialog, and here's the ever popular show async command. You can see it still has that capital S, whereas we use it with a lowercase s when we use it in our apps. And when you create a component in your project, you get a WinMD file too, and you can ILDASM that just the same. Now, the debugging is something that you should note because you're working with two completely different assemblies. So when you want to debug this, there's something you should know. And let me just be the first to tell you how that works. So if I look at my project here, if I go to its properties, by the way, the shortcut there is Alt-Enter, and then I can go to the debugging, and I'm going to be running it to the local machine, so I'm interested in setting the configuration for the debugging on my local machine. You'll see that the debugger type is set to script only. Now, script only is referring to JavaScript, and my other options there are native, managed, or mixed, native and managed. Now, you'll notice there's not like a mixed script and managed or script and native or anything like that. If you're working with script, it's just script. If you're working with managed code, you really get that added advantage of being able to look at the managed and the native, debug into the managed and the native at the same time. Let me show you what I mean. So here's script. I'll hit OK. I'll go to my script file, and under do the math, actually under this, just right here under do the math, I'll just set a breakpoint because I'm going to be hitting that. And then I'll flip over to my calculator CS. This is the C# component, and inside the add method, I'll hit a breakpoint. And then I'll flip over to the CPP, and inside my add method, I will, as you guessed, hit a breakpoint. Now we're going to run the app in debug mode. The shortcut for that is F5. So now it remembered what page I was on, jumped me right back to it. Let me enter a number, and as soon as I do that, my debugger runs. But of course, I haven't entered my other number, so I'd like to continue and get that other number. So there we go. Now, I've debugged into my JavaScript, but I have a breakpoint on the CPP, and it's not being hit. In fact, it's even telling me I'm not going to be able to hit this because you're in script mode. So I wasn't able to load the symbols for this. So I'll go ahead and continue, stop debugging there. That's Shift F5. Now I'm going to go change my properties and change that debugger type to managed and native. I don't know why you would use just managed or just native. Usually you want to use both at the same time. That way you have that added advantage, but you don't get the script. So now let's run this, F5. Give it a second. We'll load all of our demos. One of those demos is the components demo. And that should be here in just a second. Actually, I wonder if it's already broken. And by broken, I mean stopped at the breakpoint. No, all right. So I'll go back into the components demo. I'll add a number. And what do you expect to see? You expect us to stop at the breakpoint in the CPP, in the C++ file, and not at the script one, because we're now in managed and native. And in fact, if I hit F5, I'll then stop at the C# component because my script was calling into both of those components. But I never did stop at the JavaScript. So if you want to debug, just remember you have to switch between script and native and managed, but you can't have your cake and eat it too. So in this module, we talked all about background tasks. You heard from Michael on those. And we talked about pulling some of your code out of your project, putting it into a WinRT component for the purpose of modularity, performance, or on a vanity subject, just for the purpose of language preference, language bigotry, perhaps we'll call it. But anything you want to add to those points, Michael?
Well, actually, maybe just based on some user feedback that we've been having through the chats, one thing that I would want to highlight is that the Code Show app that is currently in the store doesn't have some of our demos that we're doing today. So, but if you go to the Code Show Codeplex project, that's current. So I just want to highlight that for everybody.
Yeah, that's a good point. Thanks for bringing that up. We'll go through the store certification process, do an update to the Code Show app in order to get some of the latest stuff in, but unfortunately that wasn't able to happen before we started.
That's all I have.
All right.
Yeah.
Okay, well that concludes the first module. If you don't have anything else to add, we'll go ahead and call that quits. Was there was no more discussion to highlight?
Nope.
All right.
I think you covered it pretty good.
We're good. Thanks for joining us, and we'll see you at the next module.